Hello everybody, welcome back or welcome. Today I will be teaching you how to create your first OpMode, as well as choosing a drive base that is best suited for your robot. And at the end I will also teach you how to control independent motors. And so, firstly I'd like to teach you how do I know which drive base class to use. So, in FTCLib, there are three drive base classes: differential, holonomic, and mechanism. These all extend the robot drive class. Firstly, there's the differential drive base class. This actually is different from the others as it contains two different kinds of drives you can use within it. The tank drive. You can control each side with a different stick. So it takes in two input values, one for the left side, one for the right. And for example, you could use the left Y values to move the left side, the right Y values to move the right side. The arcade drive is a bit different. It also takes in two inputs. However, it uses one value to turn and one value to move forward and backwards. So for instance, the Y value of the left stick would be used to move forward and backwards of the entire robot, and the X value of the right stick would be used to turn. Next is the holonomic drive base. This is typically used for robots with only 3 motors that can move in all directions. And they usually have something like Omni or mechanism wheels. And so these take in 3 different inputs. They take in one for strafe speed, one for forward speed, and one for turn speed. So for instance, you'd want to put in the left X for strafe speed, the left Y for forward speed, and the right X for turn speed. And finally, you have the mechanism drive base. It's a lot like the holonomic, but with four motors. It takes in 3 inputs, and each are the exact same: strafe, forward, and turning. And so next I'm going to switch over to Android Studio and show you how to program your very first OpMode using a mechanism drive base. So here we are in Android Studio, and I'm going to make my first class. And so first thing I want to do is right click, new, Java class, and name it whatever you want. I'd probably name it teleop, as that would be easiest to get to. But for purposes of the tutorial, I'm going to be naming it Megumine. And so typically either click remember don't ask again and click add, because later on I'll be teaching you how to push this to your very own GitHub. And so here I am with the class. First thing I have to do is extend linear OpMode. And then if I hover over it, I can just click implement methods and click OK. And the reason I want linear OpMode is that gives me all my methods for my OpMode, and it will make it easier to make my teleop. And so something else you actually have to do is above this public class area is add an annotation to tell the phone that this is a teleop mode and that it is controlled by the player rather than autonomous. So first you do @teleop and then name equals whatever you want to name your teleop. For the purpose of this tutorial, I will name it explosion. And so now you're given public class, whatever you named it, extends linear OpMode, and then this method which you grabbed from that class, as well as telling it this is a teleop and that the name is explosion, or whatever you named it. So first thing we must do is we gotta bring out our motors. So The most common practice to do is, so we need 4 motors since I'm doing a mechanism drive. And the most common practice is to just use FL for front left, FR for front right, BL for back left, and BR for back right. It's just a common practice, and it's a lot easier to type and read than saying something like back right motor. It's much quicker and efficient. And also, you'll need to import each class as you go. So for this, I have the motor class, and something Android Studio has is I can just click Alt-Enter. And then all this comes up, and I just have to click Import Class. And so next, we need to grab the mechanism drive class, located in FTCLib Drivebase, and name it either m_drive or drive or mech drive, something like that. Something easy to identify. And finally, you need to create your gamepad X. It's just like an improved version of the FTC SDK gamepad class. And so I do gamepad X, and for this, since it's going to be driving, a good thing to name it would be driver op. And I also have to import that. And so these are the 3 things you need up here above your override annotation. And so next we need to assign these objects. So driver op equals new gamepad X gamepad 1, which is a value that is given inside of the linear OpMode class. Oh, excuse me, I missed an R. And so next we'll go through each one of our motors and give them values. So FL equals new motor, and then hardware map, and then the ID of the motor, which is going to go into the config. So when you're setting up your config for the robot, which I may go over in a later video how to do, you need to give each motor a value for it to refer to. So typically you just give it the exact same name that you gave it here. So FL, and then what I'm going to do is I'm just going to copy, and then I'll do FL, FR, BL, BR, and then I'll go back over here to the IDs FL, FR, BL, BR, and then there you go. These motors are there now. And so next what I'm going to do is I'm going to create the mechanism drive object. So m_drive equals new mechanism drive FL, FR, BL, BR. And so I know to put them like that because if you look right here, if you hover over mechanism drive, you'll see it takes in each input. Like these are the parameters: the front left motor, front right motor, back left, and back right motors. And so that's how I know which order to put them in. And so next what you want to do is you want to do the whole, you want to type in the wait for start method. And so what this kind of does is it puts the whole op mode on pause until the start button has been pressed. It lessens the amount of errors that you could get, like, or something. It stops something from messing up. And so then you do while op mode is active, like this. So while the op mode is going, while this teleop is active, your drive name m_drive for me, dot. We'll look at field centric another time. For now, we're gonna do robot centric as it's a lot more simple to use. Dot robot centric, and then next we'll input the values we want to drive. So as you see here, strafe speed, forward speed, and turn speed. These are the 3 important things. So what I like to do, and what most others like to do, is they like to make the strafe speed the left stick, the forward speed the left stick but its Y values, and the turning speed the right stick X. And so you may be asking, how does it know what speed to go? How does it know if I'm pushing the left stick left all the way? How does it know to go what speed to go? It essentially goes off of percentages, kind of. So the sticks go 1 to -1. So left X, if I push it all the way to the left, it goes to -1. If I push it all the way to the right, it goes 1. Same with the Y. If I push that all the way down, it's -1. If I push it all the way up, it's 1. And so now let's talk about motors. So let's create a new separate motor from the drive called Shinji. So this separate motor, I can control it. First I've got to give it its a little object. So Shinji equals new motor, same as the ones for the wheels, and then give it a value you can refer to later on, such as Shinji again. And so what you're given here is this extra motor. And so we can control this motor and this, such as this. So Shinji.set, and then you input the motor power. Motor power can only go from -1, so counterclockwise, all the way to 1, clockwise. And it operates at percentages. 1 is maximum, so, and then 0.5 would be half, 0.3 a third, and 0 would be it's not moving. And it goes the exact same for the negatives, so -1, -half. And so that's how the left X and all this stuff is able to be put into here. What this is essentially doing is this is saying if the person presses, for instance, left on this, then these motors will be set to this direction at that much, at that however far you press that stick. And so, for instance, with the forward speed, if I were to press it up all the way, it would set each of these motors all to 1.0. If I were to press it down all the way, it would set them all to 1.0. And so, right here, if I want to control the Shinji, I do if driver op dot, for instance, get button dot a, and so you see gamepad keys dot button dot a. Then you can set Shinji to whatever power you'd like, so 1. And you've just made it so whenever you press A, this Shinji motor gets set to 1. And if you want it to turn off, else if, and then let's just copy that, and then set the key to B. You can do shinji.set 0. So when you press A, this extra motor known as Shinji will turn on to max speed, or if you wanted it to, you could put a 0.5 for half speed. And then if you press B, it will turn off. And so that is how you make a basic teleop. That is how you choose a drive base, and that is how you control motors that are not a part of the drive base. Thank you for watching. That is all I have for today. Later on, we will talk about more complex stuff like the motor X class, field centric, how to make the other drive bases, how to use those, as well as command base. But for now, this is exactly how you make a basic teleop. This is all you need for when you're using FTCLib. And so thank you, and goodbye.